Hello, I'm Brian May, Vice President of Product Management at Profound.js. In this video, I want to show you what you can do when you're building a Profound.js or Profound API application, and you need to go beyond what the low-code system provides. Whether you are building a new API interface with Profound API or developing interactive applications with Profound.js, you will always be working within our powerful low-code environment. But what do you do when you need to do a little more than what the low-code environment allows? Within our flexible low-code environment, you're never restricted to only the plugins that we have developed. There are a few different ways that you can expand the low-code system. One is to create your own custom plugins. Now, this requires some Node.js expertise and as well as some knowledge of the way our framework works in order to build out a custom plugin that will then generate code to be run at runtime. This is often a little more than most customers want to take on themselves. You can put your own custom Node.js code anywhere within the low-code system, whether it's an entire API or application, or even just a single step within a low-code workflow. This allows you to do any kind of custom processing that you would like, even bring in external NPM packages and integrate them into your low-code workflow. A better way, and the way we will be taking a look at in this video, is to create reusable modules. Within the low-code framework, we have the concept of module files. A module file is a file that contains multiple reusable routines made up of low-code steps, custom code, or a combination of both that can then be called from any Profound.js application, Profound API workflow, and even from RPG programs on IBM i. For today's example, we're going to be taking a look at building out a module with routines for encryption and decryption. I was speaking to a customer just the other day that asked if we had a plugin for encryption in the low-code system. I told him that at this time we do not, but there was no reason he couldn't build a module and then have that functionality available to all his applications in one reusable piece of code. After that conversation, I decided to go ahead and build this example and build a video around it. So in this example, we will be building out a module for encryption that allows us to encrypt and decrypt using a popular encryption algorithm and have that within a reusable routine that we can use from various applications. So let's take a look at our example. You'll notice to start out, I have a workspace called encryption-example, and that's just where I'm going to have all of my files for this particular example. So we'll start out by building our module. If we look here, you see I have a file called encryption.module.json. Let's open that up and I can show you exactly what I did. So you'll notice there are two routines inside of the encryption module. I have one called encrypt string AES and one called decrypt string AES. So the encrypt string AES has one step in low code. You'll notice I have input parameters of the text that I want to encrypt and secret key, which is the key that I'll use for my encryption. On the output parameters, I have IV for the initialization vector and then the encrypted data to send back. Now, if we take a look at my low-code step, you'll see here that I just have some custom code. I'm using the built-in crypto module that comes with Node.js. So no extra NPM packages involved here, but you could use the same method for using NPM packages within your low-code applications. So if we take a look at the code, you can see here I'm requiring the crypto module. And the algorithm I'm using is AES 256 CBC. I am generating a random initialization vector. The initialization vector is used to make each encryption unique so that it's more secure. So then I am creating my cipher, passing in the algorithm and the key that I want to use, but making it into a buffer and my initialization vector. And then my encrypted text, I'm concatenating together the encryption here. I'm using cipher.update to take my text and then encrypt it, and then adding on cipher.final, which is just how you finish up the encryption. And then I am passing those back out as parameters. Now, when you're doing your own custom code, your input parameters and your output parameters are in objects called input and output. That's just part of the framework itself. So you'll notice here for secret key, I was using input secret key. And then for my two output parameters, output IV, I'm changing that initialization vector to a string from hex. And the same thing, my encrypted data, I'm converting that into a string from hex. Decryption is the exact opposite. You'll see I'm passing in the encryption key that was used as well as the initialization vector. You need both in order to decrypt in this particular algorithm. and then the encrypted data that I want to decrypt. My output parameters, of course, then is just one parameter, the text that we have decrypted. And then you can take a look here at my low-code custom step, and we're basically doing the exact opposite. So again, I'm bringing in the crypto module, I'm setting my algorithm, and then my initialization vector comes in on an input parameter this time. So I'm just converting it over to a buffer. And then my encrypted text that I want to decrypt, again, I need to change that into a buffer. I set, instead of my cipher, I create a decipher, passing in the algorithm and the key and the initialization vector. Then I can update the encrypted data to be the decrypted data. And then again, I concatenate the final here, and I can set my output text to our decrypted data and change it into a string. Again, you don't have to be an expert in exactly how all of this is working. Honestly, I'm not an expert in encryption either. I built these using examples that I found on the internet to guide me. But the nice thing is only one developer in your staff needs to really even know how this works. They become black boxes that you can just use anywhere. So now I have this module with these two routines that I can call from anywhere. If I need to encrypt a string, I have a routine for that. If I need to decrypt, I have one for that as well. So now that we have these, I can call them from an API or from a Profound.js application, or even from RPG. If you'll notice here at the bottom, I have my IBMI call interface. So if I needed to encrypt a string using this routine, here is the RPG code I need in order to call this. I can copy this directly into my RPG program and just call it. And the same for decrypt. So now that we have our encryption module, let's take a look at an example of using it in low code. Again, we could use this inside of an API or Profound.js application. In this case, let's create a little application. I already have one built here, so let's take a look. Here you can see I have a very simple screen. It's accepting our text that we want to encrypt and what we want our encryption key to be. And then it's going to output what the encrypted data looks like, as well as the initialization vector. And then it also has an option to then turn around and decrypt the data based on the encrypted data and the initialization vector. Here within the low-code system, let's take a look at our encrypt logic first. You can see here, I just have a low-code step called call external routine. The call external routine plugin will give you a list of any modules that are available to you. You can see them here, as well as a list of the routine names within the module selected. So as you can see here, I've already selected the encrypt string AES routine. If you mouse over it, you can get information from the descriptions inside the module file itself. And then it will give us the list of our inputs and outputs. So in this case, for our inputs, I'm pulling the plain text, which was the text to be encrypted, from my screen, as well as the key from the screen. And from the output, I'm putting those into some work variables, IV saved for my initialization vector that's passed back, and then encrypted data, holding that in a work variable as well. And then you can see I have a second step here where I'm just taking those values and putting them on the fields in my screen. So encrypted data is going into the screen value, encrypted data, IV saved is going into my initialization vector on the screen. Now for my decrypt function, if we take a look at the logic for that, again, I'm calling external routine, and this time I'm calling the decrypt string routine, and I'm passing in the key from the screen, the initialization vector from the screen, and the encrypted data from the screen, and holding that into a work variable called output text. And then I have a second step to put that to the decrypted data field on the screen. Very straightforward. So now we should be able to come over here and just run this example application. So I'm going to launch this in a browser tab, and let's encrypt some text. So let's say we want to use modules rock. And our secret key, I'm just going to use some random letters and numbers here to create my key. And I'm going to choose encrypt. And as you can see, I have my encrypted data here, as well as my initialization vector. I need to have both of those to decrypt this text at a later time. So let's choose the option to decrypt, and you can see it uses those two values, and we get the exact same text that we started with. I hope this example has opened your eyes to the possibilities when it comes to custom code and the reusability within the low-code system. Whether you're a Profound API customer, a Profound.js customer, or both, You can take advanced functions and wrap them up so they can be easily reused within all of your applications. I hope this example has opened your eyes to the possibilities of creating custom reusable code within your low-code applications. If you'd like a copy of the code from this example, find the link in the description below. If you'd like to learn more or schedule a demo, please visit us at profoundlogic.com.